Hello, welcome to this Electric Circuit 1 class. At Fuller's College, this class is called Electric Networks 1, but actually what's being covered here in this class is literally Circuit 1. So what you are going to learn here is fundamentals of voltages and currents and the methods to analyze linear circuits. And so whatever is going to be covered here in this class will be super important for any upper level circuit design classes in the future, analog circuits, digital circuits. So make sure, please, do well in this class. So it's going to be easier in the future. Okay. So the first class here, the first lecture, we're going to cover fundamentals of voltage and currents. So let's understand what are voltages and currents. Probably you have heard about this before, but what are they? Okay. So for example, right, so this is a battery. You have seen this before in the past or everywhere in real life. And this is equipment. It's called multimeter. And so this one can test or can measure what is the voltage between these two terminals. So you know this is the positive terminal, this is the negative terminal. And if you see the readings, the voltage reading here is actually 3.7 volts. And I'm supposed to get 3.7 volts if this is fully charged, but I'm just trying to show you how to measure the voltage between these two terminals of the battery. So let's take a look. So you want to look at this LCD monitor. Sorry about the light. I hope you can see it. So let me give a little angle here so it's easier to tell. So I'm gonna probe the two terminals of the battery, and you will let me know what you are going to see from this LED monitor. Okay, let's take a look. If I measure here, right, and then the other terminal. So it's pretty close to 4 volts. So this is fully charged. It's not exactly 3.7 volts, but it's similar, which is fine. So that's how you measure it. So whenever you are talking about voltages, it's actually one terminal compared to the other terminal, right? Keep in mind, all the voltages are relative. If I draw the battery, if I draw it here on the paper, like this, so the battery, because of the chemical reaction inside the battery, it actually has electrons accumulated as a cathode terminal, and the positive ions accumulated at the anode terminal. It's called anode. It's called cathode. Okay. If there's no connection between these two terminals outside of the battery, there won't be any electrical current flow through the battery or from the terminal, from the anode to the cathode. So which means these will be just static charges stay there and waiting for something is going to happen in the future. But before you make a connection, nothing will happen. And in the schematic we are going to use in this class, the symbol of a battery actually looks like this. Okay, so that's an anode, that's a cathode, and you'll know that the anode is going to accumulate all these positive ions, and the cathode has electrons. And electrons carries all the negative charges. Okay, if you make a connection, for example, okay, so here's a battery, and if you make a connection between the anode and cathode, just use the metal wire, because the metal wire is conductive, like a copper wire, any other type of metal wire. The electrons, stay at the cathode. It's going to flow through the wire and to the anode, because the positive ions at the anode is going to attract the electrons at the cathode and form this kind of electron flow. And then we define the other direction, so the direction opposite to the electron flow's direction as the direction of the current. So this is called I, and we call it current. And the current is a vector, so it has a direction, or also has a quantity. So this is a direction of the current, which is opposite to the direction of the electron flow. Just keep in mind, this is the concept, right? We have been doing this for a while, not, probably from 100 years ago, we have been using this kind of direction to define the direction of the current. So just keep in mind, never messed up with the direction of the electrons. So this is how that works. If you have a potential difference, we can say you have a charges accumulated here, which is going to form we're going to say it's a positive potential, and this is a negative potential, and so it forms a voltage potential difference. Okay, if you connect these two using a wire, it's going to make the electron flow to the anode, and the other direction we define it as direction of the current, but there's nothing, so the ions is not flowing. Okay, so they are just protons, and they couldn't move. So what actually is moving in the wire is actually the electrons. We just define the other direction as the current direction. Okay, so that's one of the most important concepts you want to understand. And the second one, which is just trying to let you know, if you see a battery, that's the first one, which is the current flow, and the second one, it's trying to let you know the voltages across this. Sorry, I didn't do it really well. So here, if I label this guy as a 1.5 volts, and you should know that this is actually the voltage difference from here to here, right? So if I label this one as voltage 1, voltage 2, and V1 minus V2 equals to 1.5 volts, right? So the battery, and so this battery has a 3.7 volts rating, but if you have a different voltage like 1.5 volts, which is the potential difference between the anode and cathode, which is actually use the potential here at the anode to subtract the potential at the cathode to get this value. Okay, so the battery is trying to form, or it forms that potential difference, which can force the electrons flow to the anode, which forms the electric current flow. Okay, and because all the voltages are relative, so whenever you are comparing all the voltages, you have to know what is the reference. For example, this is a voltage potential. So for all the different bars, and this is 0 volts. Okay, there's no voltage at all. Okay, and this is 1 volt, 2 volts, 3 volts, 4 volts. And if I say, hey, this point, this level, voltage level is 4 volts, I'm comparing to 0 volts. And normally we call the 0 volts terminal, we call it ground. So it's electrical ground, or GND for short. Okay, so this point, this voltage potential level compared to ground is 1 volts. Okay, so this is 2 volts compared to the ground. This is 3 volts compared to the ground. This is 4 volts compared to the ground. So normally we will not say it all the time. Like, what's the voltage here? Normally we'll say 4 volts. But what I didn't say is this is 4 volts compared to the ground, which is actually 4 volts minus 0 volts, and I'm getting 4 volts. So I just didn't say it, right? But sometimes, if you want to specify where you are comparing to, you need to tell that. So, for example, what's the voltage here compared to here? Okay, it's going to be 1 volt. So the voltage here compared to the 3 volts, it's going to be 1 volt, not 4 volts. So it's always relative. It's like all the different floors in the building. This is the base. This is the first floor, second floor, third floor, so on and so forth. And just do this kind of comparison is easier, probably easier to understand it. Okay. And the next concept is called Ohm's law. All right. Pay attention. This is pretty important. And you may see all the different definitions for Ohm's law, but the very essential concept for this, number one important theorems or law in electric circuit analysis, which is actually, you can very simply describe it as if. So for example, this is a component, it's called resistor. It's just a little tiny component being used in the circuits. That's a resistor. If there's a current, electric current, flows through the resistor, it's going to form a voltage drop. So which means the voltage here will be higher than the other side. And that's it. That's the essential meaning of Ohm's law. Just keep in mind, right? So how to describe Ohm's law? You got a resistor, you pump current through the resistor, you got a voltage difference. So here will be higher than here in terms of voltage. All right, keep in mind. And the voltage difference, we call it delta V, for example, and the current is I. So in that case, if you pump current I flow through the resistor, then I equals to delta V over R. R is the resistance. So that's Ohm's law. Or you can say I times R equals to delta V, or you can say R equals to delta V over I. They are pretty much the same thing. Okay, no differences. It's just like it's actually just I times R equals to V. But you can put the other one at the denominator to look at the same result, right? So no differences. That's number one important, or you can say this is pretty much the very first concept you need to know in circuit analysis. Okay, the next concept, which is polarities of the voltage. You need to understand this concept as well. So for example, this is the battery, and the voltage reading is 1.5 volts. And if I ground here, keep in mind always ground is 0 volts. That's a 0 volt reference. So like the electric ground here in this course is different from the physical ground in your mind in the past, right? So it's not the concrete, anything here like that. It's just a 0 volts reference. Whenever I'm using a ground in the circuit, you just need to know that is a 0 volts reference, and that's it, right? So if there's any other concept in the future we're going to introduce, for example, you do have a pretty big metal piece being buried underneath the building into the soil. So, but we're not talking about that. That is a physical electrical ground, but we are not using that always. If we just build everything on a circuit board, a breadboard, we do not have that physical ground. It's just always a floating ground, and we just call it a 0 reference. All the voltages are building up based on this common ground voltage reference. Okay, so if I label here as a ground, so what's the voltage here? Think about it. Because this is a 1.5 volts battery, so it's going to force. So what does that mean is it's going to force the voltage from here to here as a 1.5 volts boost, right? So which means the voltage here will be 1.5 volts. And I didn't say compared to where, right? So the voltage as this metal piece is 1.5 volts compared to the ground is 1.5 volts, right? Or you can say the voltage difference between these two terminals is 1.5 volts. Keep in mind, the voltage difference between these two terminals is 1.5 volts because the battery forces the difference between these two terminals to be 1.5 volts. That's defined by the battery. Okay, let's look at another example. If I say the voltage reading for this battery is minus 1.5 volts, okay, so it's going to force the voltage from here to here to have a minus 1.5 volts boost. This sounds weird, but you don't need to think about that complicated. If you look at this is 0 volts and it's minus 1.5 volts from here to here. So you are going to add minus 1.5 volts to this voltage. So you are getting a voltage here, which is minus 1.5 volts. So let's look at another one. If I ground here, that's 0 volts, and this is 1.5 volts. Okay, so this is ground, this is 0 volts, and from plus to minus is trying to decrease the voltage at this point. So what's the voltage at this point? 0 volts, right? So 0 volts minus 1.5 volts. So the voltage at here should be minus 1.5 volts. And next, so this is still 0 volts because it's ground, coming ground pin, and from here to here, it has a minus 1.5 volts drop. So you are going to use 0 minus 1.5 volts. So you are getting 1.5 volts for this point. Okay, hopefully you can understand this. So there are more examples, but I don't think I am going to introduce every single one. Um, it shouldn't be that difficult. Okay, and after this, let's look at some examples about Ohm's law. So for example, that's a 1.5 volts power supply, and that's a circuit, that's a resistor, which is 1 k ohm. So ohm is a unit for resistance. 1 k means 1,000, right? So this is actually 1,000 ohms. And this is a 1.5 volts battery, and you ground here because the potential here is higher than here, so this is high, this is low, so it's going to pump the current in this direction and come back the battery. So that's the current, and according to Ohm's law, I equals to delta V over R, and delta V is the voltage between these two terminals of the resistor. And you can see here is the 1.5 volts battery, and because this is a metal piece, so it's going to conduct the potential to here. So here, 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 here has the same potential until it arrives the terminal of the resistor. They have all the same potential. So actually, the voltage difference between these two terminals is 1.5 volts. If you look at that, it's actually 1.5 volts across this resistor as well. So this is higher, this is lower. So it's the voltage difference between here to here will be 1.5 volts. And the resistance is 1,000 ohm. And you can see this will be 1.5. So the unit of current is amp, right? But you got 10 to the minus third amp, and this is also equals to 1.5 milliamps. Okay, this is how you calculate the current if you know the voltage and the resistance in the circuit. Okay, so milli is 10 to the negative third. Keep in mind. So let's look at another one, another example. So that's another resistor a ground here, and this is a 1.5 volts power supply as well, and this is a 1 k ohms. And so that's another circuit. Okay? You have to form a circuit to close a loop in order to allow the electrons to flow in the circuit. And this is a 0 volts reference, so this point will be 1.5 volts. Because 0 volts everywhere on this metal wire, so it's going to be 0 volts here. So the voltage across this resistor is actually from here to here, so that's high to low. All right, so the current will be in this direction. So I equals to delta V over R, and the delta V is from high to low is 1.5 volts minus 0 volts over 1 k ohms. And this is still 1.5 milliamps. Okay. This is how you can use Ohm's law to calculate the current, electric current from the circuit if the voltage and the resistance is given. Okay, so we are going to take a look at another two concepts, and we will pause this video since I don't want to make this too long. So the seventh concept is called dual multiplier, dual power supply. So it looks like this. So if I use a wire to connect the anode of one battery to the cathode of another battery, and I'm going to form something like this, and I will ground this pin, so this will be 0 volts, right? And because they are both 5 volts batteries, so I'm asking what's the voltage here and what's the voltage here. If I just saying what is the voltage at this point, so I'm comparing to the ground, keep in mind. So because this is 0 volts, and this battery is going to form, you will force the voltage here to be a 5 volts increment, right? So it's going to be 5 volts here. So what about here? Because this is 0 volts, and this is from high to low, and high to low, right? So high to low. So this battery is going to force the voltage to drop by 5 volts. So the voltage here will be 0 minus 5 volts, which is negative 5 volts. Okay, this is a very important application, and you're going to use this kind of dual power supply to power up the amplifiers being used in analog circuit design in the future. But we're going to learn something about that as well in this class. So the very last one I'm going to introduce in this video, in this lecture, is voltages in an open circuit. So something like this. Okay, this is the 5 volts battery, and this is the 1 k ohms. So what's the voltage here? What's the voltage here? So definitely this one is 0 volts, no problem. And you are probably saying, hey, this is 0 volts as well because, sorry, it's frozen. So this is 0 volts as well because there's no electric circuit and there's nothing flowing, no electron flowing here because it's not closed, right? So the electron has nowhere to go. However, it's wrong because keep in mind, in Ohm's law, if there's no current flow, there won't be any voltage drop. Okay, so which means there's no current, right? So you're thinking this is a higher voltage, lower voltage, so it's going to pump the current. Wait, there's nowhere to allow the current to flow. So there's nothing. Or we can say the current is 0, right? According to Ohm's law, V or delta V equals to I times R, which is 0 times 10 k ohms. It's going to be 0 volts. So which means the voltage difference between these two terminals will be 0 volts. And what's the voltage here? Definitely 5 volts because the battery made it, right? So and no difference between here and here which means the voltage here will be 5 volts as well. Okay, keep in mind, this is a very important concept. All right, I think that's everything I want to cover in this lecture. I'm going to introduce more concepts in the next. See you in the next video.